Lawn sprinkler systems or irrigation systems for grass, natural areas, whether that be mulch, pine needles, bushes, nandinas, azaleas, boxwoods, whatever one may have planted in the natural areas. The question here in the topic is how much pressure is adequate pressure to run a system, a sprinkler system, and a drip line? We have actually we broke it down into certain segments here, and the irrigation system, just we will include that as an entire system, including the drip line and the regular irrigation. So the regular irrigation, the good working pressure should be between 65 and 75 psi. The drip line, the inlet pressure should, perhaps a good pressure would be 65 to 75. On the outlet pressure, keep in mind 35 psi. If one actually does not put a reducer on it, and a reducer may look something like this right here. So this gives you the inlet side, this gives you the exit side. So when one exits there at about 35 psi. So again, so inlet pressure, which would be this side here. A good working pressure would be 65 to 75 psi. That's on the inlet side. When it exits, the pressure should be perhaps a good workable pressure is 35 psi. And one may ask, well, I really don't want to spend the money on putting an extra reducer in there. Good question, and most of us don't. However, when installing, if you install it and you fail to put something of this caliber to reduce the water pressure, I'm not sure how many different manufacturers there are, or if there are different manufacturers. However, if you fire the drip line up and you start noticing leaks, popping holes, etc., that's because your pressure is too high. So now let's reiterate. We will say the irrigation system is the total system for the lawn. Okay, we have a total system for the lawn. The regular irrigation, what we'll call the regular irrigation, will be the grass area per se. Okay, a good working pressure will be between 65 and 75 psi. Anything below 65 is very questionable, and you perhaps may have to zone it out more to keep the pressure up. And what I mean by that, if you put 3 zones, you may end up having to put 4 or 5, because you need to keep the pressure very robust in order to drive the heads, to pop the heads up, because the heads work off of water pressure. And if the pressure is above 75 psi, one may need to install a pressure reducing valve different than this pressure reducing valve that's adjustable, and that would give one the range between, say, 25 and 75 psi, because anything above 75 psi will actually compromise the system. What I mean by that is one may find elbows popping, couplings leaking over time, etc. So again, if one can keep the workable pressure. Now, how does one get this pressure? One inherits the pressure from the water company, so they have no control over that. And then they can do a static test, screw a meter tester onto the hose pipe and do a static water pressure and determine what your water pressure is. If it's too high, get you a pressure reducing valve. Sometimes one may be able to call their water company, and at that point, the water company, somebody in the engineering department, may be able to tell you what particular pressure you have from neighborhood to neighborhood. So I'm not certain on that, but I would just get a tester for about $10, screw it onto your hose pipe, make sure everything's off, and then open the hose pipe wide open, and that should give you your pressure. And then you know what your pressure is. If your pressure is above this, you'll need a pressure reducing valve. If your pressure's in this range here or somewhere plus or minus, then you may not need a pressure reducing valve on your system. And if you don't put a pressure reducing valve, you're going to end up having problems down the road, perhaps. Okay, so we go from the regular drip line. This would be the grass area. This is the natural area, say the mulch, the landscaping, the bushes, etc. We have an inlet pressure of 65 to 75 psi. So that would be this side here. Say we're coming in at 65 to 75 psi. A good optimum working pressure for the drip line. The drip line cannot hold the pressure that the regular sprinkler system needs. So a good working pressure for the drip line would be about 35 psi. So if we look at this, it says 35. So if we come in at 65 to 75, if we exit at 35, this would be optimum pressure. So, and all things being equal, if the system is installed properly, then at this particular point, your system should work fine. Well, and there will always be leaks perhaps down the road, but at least if you keep this workable pressure. One other tip here, I do like to put these in a box, a rectangular box. So this way, if mulch, if you come back and put mulch, if you come back and put stones on your landscaping, if you come back and put pine needles, this is not obscured. You can pop the lid on the box, access it. I'm not sure how often these need to be changed. I put several of these in, but to be honest with you, I don't know if I've ever even changed one. So I don't know how hardy or how durable or how long lasting they are, but I don't know that I've actually gone back and taken one out and replaced it with another one. But again, let's reiterate here. 65, 75 psi in, 35 psi out. This is for the drip line, for the natural area. So 65, 75, inlet pressure, outlet pressure, this is the magic number, 35, somewhere plus or minus, not an exact science. Now on your regular sprinkler system, 65 to 75, same thing as this pressure here. This would be coming from your street, so you have no control over this. If it's high, you put a pressure reducing valve, you can control that. But if your pressure is between 65 and 75 psi, this is a good workable pressure for the lawn irrigation for the yard. So again, irrigation, regular irrigation, grass area, 65, 75. Drip line, natural area, inlet, 65, 75. Outlet, 35. If you don't put this reducer on here, you may have leaks and you may have problems. Thank you for watching and have a wonderful day.